Hello, this is Algebra B, page 4, notes, questions 21 through 25. Question 21 focuses on what's called function notation. In all the previous examples, we've been using y instead of f of x. So we've had something that says like y equals 2x plus 5. We've just replaced y with f of x. It's just a different way of noting for functions. A lot of times we use it if we're going to be plugging in certain inputs or certain numbers into that function, but it essentially means the same thing. So the question first asks us to find f of 0. What that means is anywhere in the equation where there's an x, you're going to replace it with the number in the parentheses. So we're going to replace it with 0. Make sure you use parentheses as you're replacing things. So 2 times 0, switch out 0 for x, plus 5. If I actually go to solve this, 2 times 0 is 0, plus 5 equals 5. So f of 0 is equal to 5. You can write this as an ordered pair, which is 0, 5. Next, we're going to find f of 4. We are going to do the same thing, so I'm going to replace x with a 4 this time. So 2 instead of x, I'm switching it out for 4 plus 5. f of 4 is equal to 2 times 4 is 8 plus 5 is 13. So it's the ordered pair 4, 13. Very similar setup here. It's just a different function, this time having an x squared. So wherever we see an x is what we're going to replace. So I'm going to replace that x with 1 here to find f of 1. So f of 1 is 1 squared is just 1, plus 10 equals 11. This would be the ordered pair 1, 11. If I went to find the function f at -1, I would replace the x with -1. And the cool thing about when you square a number is you're going to get the same thing whether it's positive or negative. So -1 squared is -1 times -1 is just positive 1. Plus 10 is also equal to 11. So this would be the ordered pair -1, 11. That's all for the function notation. Here we're asked to draw an example of something that is a function and not a function. What we need to know is something that's a function has to be able to pass what's called the vertical line test. So I'm going to draw one example of a function. So this is a function. I know it's a function because if I were to draw an infinite amount of vertical lines, it can only hit that graph at one point at a time. So it passes because not in a single one of those vertical lines did I ever hit that graph in more than one spot. So it is a function. Over here, this is an example of not a function. If I were to draw vertical lines, it would hit in multiple places. 1, 2, 3, 4. So this is not a function. So if on the test you're asked to draw a function or not a function, make sure that a function can pass the vertical line tests. Then not a function, it needs to fail that vertical line test. So some other functions that you could have drawn were, linear. If it's going diagonal, you could have drawn horizontal line. Parabola is an example of a function. Anything that when you draw it, it would be able to pass that vertical line test. A few examples of not a function over here. If I had a sideways parabola, if I had a vertical line, it would fail the vertical line tests. Anything that's going to have two lines basically on top of each other is going to fail. Next up, we have question 24. It asks us to graph the system of linear inequalities. A system means you're going to have two equations or two inequalities that you are graphing. So I'm first going to start by graphing the top equation. I'm going to graph it in red just so you can kind of see the difference of the two equations. It's in slope-intercept form, so I'm going to remind myself that slope is the number with x. The other number is the intercept, and we always graph the intercept first. So I'm going to put a point at 2. And then I'm going to use the slope, which is 3 over 1, to go up 3 over 1. When graphing inequalities, it's important to pay attention to the sign. So right here, it's greater than or equal to. If it has that line underneath, it includes the line, so that means this can be a solid filled-in line. Unlike the next one, it does not have a line underneath, so it's going to have to be a dashed line when we go to do it. So this time I'm going to graph the y is less than 3. Similar to when we graph that horizontal line when it's just y equals something. It's going to be the same situation here. Put a point at 3. It should be a horizontal line, but since, again, we have this sign that does not have an or equal to, it's going to be a dashed line across here. It will not be solid. That's because anything that's on that line is not part of the solution. The other thing to know about graphing inequalities is you have to shade the region which includes both of them. So the top equation said that it is greater than or equal to this line. So we need to be looking at one of these two spots because this is what is greater than the red line. If we look underneath that line, those y's are going down, so that's less than. But less than the blue line. So we need to be looking beneath this blue line. The area that they both had in common is this area, so that would be what's shaded. Any point in this region would make both of these equations true. Or both these inequalities true. Question number 25. Again, we're graphing inequalities here. So I'm going to graph the 2/3 x minus 1. We're going to start by putting a point at -1. That's our y-intercept. Then use our slope 2/3 up 2 over 3. It is a less than or equal to, so again it's going to be a solid line because it has that or equal to sign. And then for the other one, it's y is greater than 1. So right here is where y is 1. Since it does not have that or equal to sign, it is going to be another dashed line. So dashed across here. Again, nothing on that line is included. And we have to figure out what area to shade. So for the red line, it says y is greater than 1. So we're looking at a region up here. For the blue line, it says y is less than that line. So we're looking at any area here or here. What they have in common is this tiny area over here on the side. And these are the coordinates that will make both of the inequalities true. That's it for these notes. Open up the Algebra B page 5 notes to continue.